Okay, so section 7.3, similar triangles. Um, Basically, this section is about proving triangles similar. A lot of it's going to seem somewhat familiar because we did a lot of this back with proving triangles congruent. A lot of the same ideas and basic properties, just different way we handle things. Um, so let's see here. We've used angle, angle, side, and side, 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 and side, angle, side congruence to prove triangles are, congruent. Now we're going to use angle angle similarity and side 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 and side angle side similarity to prove that triangles are similar. We're not going to do any solving here today. I'm just going to go through in this video, kind of identify how they are similar, and then in class we'll do the solving problems. So first postulate, postulate 7.1, angle angle similarity. Um, if you need to, pause me to copy it down. Otherwise, if you can copy it while I'm talking, go with it. But basically, if we're going to prove that two triangles are similar, all we really need to do is prove that two pairs of angles are congruent. If you can do that, you can prove that they're similar. Some books actually do angle, 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 where you prove all three pairs of angles congruent. But we know once we have two pairs of angles congruent, third pair is automatically congruent by the third angles theorem, so we don't have to mess with that. Okay, so pause me if you didn't get that copied down enough yet, the statement, the example, and the drawing, because I'm going to go to the next slide now. All right, so the question is basically, hey, are these two pairs of triangles similar? If they are, how do you know for sure? And then what's the similarity statement? And that's a lot of times pretty common in the homework, and on the test I make you do that as well. So if you know, I'm going to ask you, it's going to pop up, say, hey, for this first one here, 1A, are these similar? You'll say yes or no, and then it'll tell you if you're right or wrong, and we'll come back to me. So, it's going to come up here in a second. Okay, so number one, or 1A, I should say, 1A. The question is, are these similar? Now, what we need to do is for this right now is prove that we have two pairs of congruent angles. We know we already have one pair of congruent angles because we have right angles. So D and C are congruent, so we're good there. So the next question is basically, are the other two pairs of angles congruent? And some of you would instantly say, no, B and F aren't the same. One's 44, one's 47. But what we need to do is check to see, wait a minute, what about A and G? Because this is a right triangle, maybe those guys aren't congruent, but A is maybe congruent to F or B is congruent to G. Well, these are right triangles, so we already have 90 degrees taken up. So it means there's only 90 degrees left for A and B. And if this is 90, that means that that A has to be 46 degrees, which does not match with F at 47. So no, actually they're not similar because those aren't congruent. Same thing with F and G. If this is 47, G would have to be then 43 degrees. So no, not similar. Now it's pretty easy to work out. Okay. All right, then now we'll go back to example 1B. Okay, are these two similar? So again, same thing. Question's going to pop up. Say yes or no. It'll tell you if you're right or wrong, and then we'll walk through me doing the problem. Okay. All right, so here's 1B. And the question is this one similar? And some of you probably just said yes, because the first one wasn't, so the second one must be. And that's a good guess. The thing is, it actually is true. They are similar triangles, and it's by angle, angle, and you have a couple different ways to look at this. Hopefully you catch, hey, parallel lines, parallel lines. Hey, remember the good old FUN telling you consecutive angle supplementary, and then the N shape or the Z shape and the F shape gave you congruent angles because of the fact that they're corresponding. Well, that's what I have here. Angle P corresponds to angle J, so they're congruent. Q corresponds to angle K because they're congruent with the two parallel lines. So yes, this is actually they're similar. Now, the tricky part about 1B, though, is sorting out the triangles because they're actually overlapping. You have triangle PLQ, and I'm actually going to do it with highlighter. Let me highlight that guy. PLQ. And then you got the big triangle JKL, and I'm going to redraw that one. Or sorry, JLK. And some of you I know you can visualize these guys perfectly fine. Some of you are just not. It's not your thing. But J is congruent, K is congruent, L. So I know these are similar by angle, angle. That's your justification. No. Are they similar? Yes, angle, angle, similarity. The similarity statement then would be PLQ is similar to triangle JLK. JLK. And P has a single mark, and so does J. L has no mark, so they correspond. And then K and Q have the double marks. Okay, so there we go. All right. Now there are two other similarity theorems. The first one is side, side, side. And that just means if you've got all three pairs of sides corresponding are proportional. So basically you don't know anything about the angles, but JK over MP is the same thing as JL over MQ and LK over QP. Those are all the same. Guess what? They're similar. Side angle side, we already had side angle side with congruence. Now we're going to have side angle side with similarity. That's 7-3. And how that works is you have one pair of angles congruent. That's the included angle. That's what we call it as we get the included angles. And those are the angles between the two pairs of sides. And this time, instead of the sides being congruent, the sides are proportional. So if these two ratios are the same, and those two angles are congruent, there you go, side angle, side similarity. So pause me because you're going to need to copy this down, or you can copy it out of your book, because I'm going to go on to the next problem. So I'm not going to, sit here and watch you copy this down in video in real time. All right, so here we go. Here's our problem 2A. The question is, are these two triangles similar? Again, it's going to pop up in a moment. You say yes or no, and why. And then, watch me go through it. And then same thing for 2B, that'll go next. All right, so looking at 2A, to be honest, hopefully this one jumps out at you as your process at least, that I've got all three pairs of sides marked. So if anything, it's going to be side, side, side. Now what I have to do then is I have to figure out, are all the side proportions the same ratio? So that's where I would go through, again, mentally do this, but I can do it with a marker. LK is the smallest side with 8. PM is the smallest side with 6. So those two would have to correspond. Next smallest side is JL, which is 12. Next smallest side is MQ, which is 9. And then the biggest sides for both of these are the 16 and the 12. So what I'm going to look for is to see, hey, do all three of those sides have the same proportion? If they do, similar by side, side, side. So let's see, 8 to 6. Well, that is 4 to 3. 12 to 9. Divide those both by 3. That's 4 to 3. And 16 to 12. That reduces to 4 to 3 as well. So yes, they are similar by side, side, side. And then my similarity statement would be, I don't know, let's pick L, then K, and then J. L is between the orange and the blue. M is between the orange and the blue, so M. K is between the blue and the pink. P is between the blue and the pink. And then J is between the pink and the orange. Q is between the pink and the orange. There we go. That's my similarity. Okay. All right. The other problem then, 2B. Okay. So I have to prove, are these two guys similar, yes or no? So again, it's going to pop up in a second for you to try to make a guess at it, work it out on your own, then watch me work it out. Okay, now this one, hopefully by process of elimination, you would guess it's possibly a side angle side problem, but you do have a reason for why it is as well. I've got two pairs of sides. I don't know TZ and XY, so I can't do anything with that. And hopefully you remember your good old friend vertical angles here. Okay, I do have a pair of angles. So I've got a pair of congruent angles. Now I need to show I have a pair of proportional sides. So let's compare the sides. Well, again, using the kind of trick of biggest and biggest and smallest, TW and WY are the two smaller sides. ZW and XW are the biggest sides. So that means then, let's see if those guys are the same proportions. Well, 10 to 20 is 1 over 2. 11 to 22 is 1 over 2 as well. So hey, both these guys reduced to 1 over 2. The angles are congruent there between them. So yes, this is side angle side similarity. And your similarity statement, let's see, Z and X correspond. So Z and then T and then W is similar to X, y, and then w. So ZTW, ZTW, XYW. Those guys are similar. Okay. All right, now let's see here next. Oh, another problem here, just kind of seeing if you could pick up a different way of doing this about the similarities. So if triangle JKL is similar to, or sorry, triangle JKL and FGH are two triangles. We know that angle J and angle F are congruent. Which of the following would be sufficient to prove the two triangles are similar? So, yeah, again, pause it if you need to. Try to make your kind of work through it, make your best guess, and then I'm going to answer the question, then I'll go through it. All right, so here we go. So JKL and FGH. Okay. Now, I'm just going to draw two triangles. Let's say I have no idea what's going on here. So draw two triangles. So J, K, L. And here's the key. We know that J and F are already congruent. So, and they'd have to, which means J and F would have to correspond. And then really it doesn't matter. I don't know. Let's put this in order as I did what? J, K, L. Let's do F, G, H. Just to try to kind of line those up as best we can. So those two guys then are the congruent pairs of angles. Now here's the tricky part about this. I don't know any other angles, and it's only talking about sides being proportional. So what that means is I need to do side angle side. So I have to do something with these two sides here and here. So what I'm looking for is the one out of the four that shows me that those pairs of sides are proportional. And more importantly, it shows me that JL either corresponds with FG or FH, and then JK corresponds with one of those as well. So that means I can actually instantly cancel off F, H, and J because all three of those use the side of GH. GH is not going to give me side angle side. So actually it really jumps us right to answer G. But if you look at this now, they're saying JL corresponds to JK, or JL and JK, JL over JK, all right? And then FH over FG. So JL corresponds to FH, which it does. JK corresponds to FG, which it does. So it would be a side angle side. That's a tricky type of problem. Yeah. Okay. Now the rest of the section then is just some properties basically. So similarity property, reflexive, you still have that. A triangle similar to itself. Symmetric property, if two triangles are similar, I can switch their order. Transitive property of similarity, if two triangles are similar to the same triangle, so ABC is similar to DEF and XYZ is similar to DEF, those guys are similar to each other. So don't have to copy that because we did plenty of that earlier on in the school year. And then the last little bit here is just a kind of a summary, and it's for you to copy down in your notes. So either you can pause this or copy from your textbook, so just cut and paste it from there. So angle says if you've got two pairs of corresponding angles congruent, you're similar. Side says if you have all three pairs of your sides that correspond in the same ratio, you're similar. And then side angle side's always the toughest one to use for this because it's not congruent, it's proportional. So one pair of congruent angles and the sides around them have the same proportion. AB over XY equals CA over ZX in this case. Okay, so there we go.